Hey guys, welcome back. Today we're looking at 3.4 domain restrictions. So we're going to slow down for the next couple weeks. We're a little bit ahead of schedule, which is good. So I think we're going to just do 2 lessons this week. So one for Monday, Tuesday, and one for Thursday, Friday. So when we're looking at domain restrictions, there are 2 types generally of domain restrictions that we can find. So one is if we have an I, and we talked about that earlier in the year. So that's if we have a negative inside of our square root. So any number that's negative in our square root, that would be one of the domain restrictions because technically it's imaginary. So there's not going to be a graph at that point or in those points. So the second one, which is what we're looking for at today, is if the denominator is 0. And if our denominator is 0, I think that you guys are used to calling the function value undefined. I'm not sure if you understand why it's undefined, so let's kind of look at it now. So if we think about division and multiplication, we know that they're inverses of each other because we can write the same statement. We can use the same numbers to write a statement in division as we can in multiplication, and they should be equivalent. So 6 divided by 2 we know is equal to 3, right? So I can always write that with the same numbers as 2 times 3 equals 6 because, again, multiplication and division are inverses of each other. Now this still makes sense if we do 0 divided by 4. We know 0 divided by 4 is 0, and if we multiply these numbers again, so we're going to rewrite it as a multiplication, then we get 4 times 0 equals 0. Right? So it sets up the same way. Now, some of you might think, all right, if we have 3 divided by 0, that's probably equal to 0, but this is where it fails. Because then, by the same thinking, 0 times 0 is equal to 3, and we know that's definitely not true. Right? Another way to think about it is if we think about grouping, right? So the bottom is how many groups? 6 things in 2 groups, each group should have 3. 0 things in 4 groups, each group should have 0. 3 things in 0 groups, now that doesn't even make sense, right? Because if we have 3 things, are putting them in a group, they're already grouped, but if you have 0 groups, then that doesn't make sense. Anyways, yeah, so the big thing we're looking for here is if the denominator is equal to 0. Okay, so we have 3 examples today. It says, or maybe 4, 3? We'll see. All right, so it says find all values of x that are not in the domain. So anytime we're looking at rational functions like we have here, right, where we have x in the denominator, we need to figure out when those, for what values of our variable in the denominator is going to make it 0. So we're just focusing in the denominator. So what plus 12 is equal to 0? That would be negative 12. If you guys have a hard time seeing it that way, then you can just set it up. We can set the denominator, u plus 12 equals 0. And then solve it algebraically. And we get the same answer. Okay, but this is Algebra 2, right? So it's going to be a little bit more complex than that. Or it can get more complex than that. So look at this denominator. We have w squared minus 4, which is a quadratic. So there's 2 ways to solve this one, right? So one way is we could just set it equal 0. And then we could add our 4. So we're solving algebraically here. W squared equals 4. Then we square root to get rid of the square. And we need to remember anytime we square root, right, in algebra and in algebra 2 and higher, we're going to take positive and negative The square root 4 is 2. Okay, second method, whoops. Second method is, hopefully, if you guys are good, you recognize this as a difference of squares. The first part, w squared, is a perfect square. The square root is w. The second term is 4, which is a perfect square again. Square root is 2, and we have a minus sign in between. So we know that that factors to be, whoops, w plus 2 and w minus 2. So we have a plus, we have a minus, and we have the square roots of the front and back, the w and the 2. And we're going to say that's equal to 0. And then we know because of the zero product property, right, we have two things that are equal to 0 when they're multiplied, that either of those things, if not both of them, has to equal to 0. So for this part, w plus 2, that would be negative 2, right? Negative 2 plus 2 equals 0. For the second part, that would be positive 2 because 2 minus 2 equals 0. So here again, we have positive and negative 2. And in the second method, we have a positive and negative 2. So if you guys can recognize that difference of squares, the faster you pick up on it, the easier it's going to get down the road. Okay, last two. So these ones we're going to have to factor a little bit. These are not differences of squares, right? They're 3 terms. All right, so we lucked out because there's no number in front of our x squared or w squared. There's no coefficient there, so these are a little bit easier to factor. So let's just go ahead and factor them. And again, we're looking for what would make the denominator 0. So we're not bothering with the top for now. We're looking at what multiplies to get negative 72 and adds to get negative 1w. All right, so I'm going to put a w here and w here because we don't have a coefficient again in front of our w squared. So the number that we multiply, the numbers we multiply to get negative 72 and add to get negative 1w would be negative 9 and positive 8. We're trying to find what makes that 0. So we're going to apply the zero product property again. What would make w minus 9 0? That would be 9. What would make w plus 8 equal to 0? That would be negative 8. Okay, last one. I'm going to factor this one again, just like we did the last one. This time we're looking at what multiplies to get negative 45 and adds to get 4. So negative 45 and 4 is negative 9 and positive 5, right? Negative 9 times 5 is negative 45. Negative 9, oops, sorry, positive 9 and negative 5, right? Because then positive 9 minus 5 is equal to 4. Okay, zero product property one more time. Negative 9 plus 9 is 0, and 5 minus 5 is 0. So those are the two values where our function is not defined and therefore is not in part of the domain. And then when you guys get to calculus, those of you who are getting to calculus, you can talk about discontinuities and domain and stuff like that. Okay, that's it for today. So again, when we're talking about domain restrictions, for today we're talking about anytime our denominator is equal to 0, and that would make our function undefined at those values. Okay, good job.